Hey gang, today we're going to be graphing some more functions to see if we can determine what makes something linear versus nonlinear. In our first example, we have y equals 3/4 x minus 5. Now, hopefully you see that as being something written in y equals mx plus b form, which is slope-intercept form. So obviously this should be a straight line, but let's prove it. So here we have to do some work by substituting in the x values to get the y values, the input values to get the output values. So here we have 3/4 of -8 minus 5. Remember my trick, you divide by the denominator, multiply by the numerator. So that's -8 divided by 4 is -2 times 3 is -6 minus 5 is -11. Plug in the -4. -4 divided by 4 is -1 times 3 is -3 minus 5 is -8. Plug in the 0. 3/4 of 0 minus 5 is 0 minus 5, which is -5. Plug in 4. 3/4 of 4 minus 5 is 4 divided by 4, which is 1 times 3 is 3 minus 5 is -2. Plug in the 8. 3/4 of 8 minus 5 is 8 divided by 4, which is 2, times 3, which is 6 minus 5, which is +1. Now we're going to go ahead and graph those on our coordinate plane. So we start with -8, -11, which is left 8, all the way down to over to the side, and all the way down to 11, 2, 4, 6, 8, 10, 11. It's all the way at the bottom. So it's this corner point down here. Okay, and then -4, -8 is left 4, down 8. This point right here. 0, -5, stay at the origin and go down 5 for the y-intercept. 4, -2 is right 4 and down 2. And then 8, 1 is right 8 and up 1. So here, if we connect our points, we have a perfectly straight line. We label it with the equation. And we now have proven that this is definitely a linear function. And we would write that this is a linear function, or this is linear, because it is written in slope-intercept form. And is a straight line when graphed. So again, as we noted yesterday, anything that's in y equals mx plus b form is going to form a straight line. Let's take a look at another example. Okay, so for number 2, now we have 10 over x plus 3. So now, doesn't really look like it's in slope-intercept form. So we want to prove whether this is going to be linear or nonlinear by plugging in the x values to get the y values, by plugging in the input to get the output. So we have 10 over 1 plus 3 is 10 plus 3, which is 13. Plug in the 2. 10 divided by 2 plus 3 is 5 plus 3, which is 8. Plug in the 4. 10 divided by 4 plus 3 is 2.5 plus 3, or 5.5. Plug in the 5. 10 divided by 5 plus 3 is 2 plus 3, which is 5. Plug in the 10. 10 divided by 10 plus 3 is 1 plus 3, or 4. So now we can graph those points starting with the 1. So 1 is up at 13. So we go right 1 and up 13, which is all the way up here. Then 2, 8 is right 2 up 8. Then 4, 5.5 is right 4 and up 5.5. So in between 5 and 6. And 5, 5. Right 5 up 5. And 10, 4 is right 10 up 4. Right here. Okay, so obviously when we connect these, we get a curved line. That's going to look something like this. Arrows in both ends, label with the equation. So we have proven that this is not a linear function. We can say this is nonlinear because it is not in slope-intercept form. And when graphed, is not straight or is not a straight line. And that's because of the x in the denominator. So we don't have a true slope here because we're dividing by a number here. All right, let's take a look at another example. So in number 3, we have 6 minus x squared. Again, doesn't look like the traditional y equals mx plus b, but we want to prove whether this is linear or nonlinear by graphing. So we're going to plug in -4. So we get 6 minus -4 squared, which is 6 minus 16, because a negative times a negative is a positive, and we get -10. Then we plug in -2, so we get 6 minus -2 squared, which is 6 minus 4, since -2 times -2 is 4. We got 2. Then we plug in 6 minus 0 squared, which is just 6 minus 0, which is 6. Then we plug in 6 minus 2 squared, which again is 6 minus 4, so we get 2 again. And then 6 minus 4 squared, which is again 6 minus 16, so we get 10. So let's see what happens here when we graph it. -10 rather, not +10. So we start with -4, -10, which is left 4 and down 10, which is all the way at the bottom here. Then -2, 2, which is left 2 and up 2. 0, 6, stay at the origin, go up 6, which is our y-intercept. 2, 2, go right 2 and up 2. And then 4, -2 is right 4 and down 10, all the way at the bottom again. So again, when we connect these points, we get a U shape because of the x squared, which once again proves that this is non-linear. So we'll write, after we label y equals 6 minus x squared, this is non-linear because it's not in slope-intercept form. And when graphed, does not form a straight line, or doesn't form a straight line. So hopefully now you've got the description for linear and nonlinear down. If something is linear, it follows the format of y equals mx plus b, and when you graph it, it's straight. If something is nonlinear, it does not follow the format of y equals mx plus b, and when you graph it, it's not straight. It's that simple. Remember, y equals mx plus b is the same as slope-intercept form. All right, so you are now going to try a couple more graphs on your own. You can try 4 and 5 on your own now. Raise your hand so I can check them before you go on. Pause the video and then you come back for the rest of the lesson. All right, so now again, we want to be able to tell if something's linear or nonlinear just by looking at some tables. So let's see what happens in these two tables. The first one, if you're looking at the x-axis, we're going up to, up to, up to, and up to. So this side is consistent. But if we look at the y side, 65 to -9 is going up. If we think about 65 minus 9, that would be 56. So it's going up 56. Then -9 to -1 is going up 8. -1 to 7 is also going up 8. 7 to 63 is like 63 minus 7, so that's 56, is going up 56 again. All right, so does not look very consistent. 56 over 2 is not equivalent to 8 over 2, so there is no consistent slope there. So this is definitely nonlinear. Because it is not changing at a constant rate. Done. Okay, so let's take a look at the other side. Now, if we look at the x's again, it's the same x values. It continues to increase by 2 each time. But if we look at the y's, 11 to 8 is going down 3. 8 to 5 also going down 3. 5 to 2 also going down 3. And 2 to negative 1 also going down 3. So the slope here is consistent as negative 3 over 2. So this is linear because it is changing at a constant rate. All right, so again, when you're looking at a table, you just want to look for whether it's changing at a constant rate to determine if it's linear or nonlinear. If it is changing at a constant rate, it's linear. If it's not, it's nonlinear. All right, so you're going to try the next set of tables on your own. When you're done with those, have me check them over, and then you can move on to today's exit ticket and maybe even the homework.